6 weeks. That's her entire life. In those 6 weeks, she'll fly the equivalent of 1.5 times around the circumference of the Earth. She'll make about a 1/12 of a teaspoon of honey. She'll work every single day until her wings literally shred apart from use. And when she dies, the hive doesn't notice. This is the worker bee, and her life is one of the most brutal arrangements in the entire animal kingdom. Here's the thing that hits you when you actually look at how a honeybee colony works. There's a queen. She lives 5 years. She does essentially one thing, which is lay eggs, up to 2,000 a day. And every bee in the hive exists to serve her and the colony she represents. The worker bee, which is every female bee that isn't the queen, lives 6 weeks in summer. Maybe 6 months if she's born in autumn and gets to overwinter. But a summer bee? 6 weeks. Hatches, works, dies. That's the whole story. She doesn't get to choose her role either. Her fate is decided by what she's fed as a larva. Royal jelly in large quantities makes a queen. Standard bee bread makes a worker. The decision is made before she can do anything about it. So she hatches into a job she didn't apply for, with a lifespan she can't extend, doing work that will never benefit her personally. Sound familiar? Doesn't matter. Keep going. The first 3 weeks of her life, she never leaves the hive. She's a nurse bee. She feeds larvae, she secretes wax from glands on her abdomen, and builds comb. She fans the hive entrance with her wings to regulate temperature, keeping the brood chamber at exactly 95 degrees Fahrenheit, regardless of what's happening outside. She processes nectar brought in by older bees, passing it mouth to mouth, evaporating water out of it until it becomes honey. She guards the entrance, she removes dead bees from the hive. 3 weeks of this, inside a dark wax structure, working constantly. Then, at 3 weeks, something shifts. Her hypopharyngeal glands, the ones that produce royal jelly, start to shrink. Her venom sac fully develops, and she transitions to the job that will kill her. She becomes a forager. The forager's life is simple and absolutely relentless. She flies out looking for flowers. She can range up to 5 miles from the hive. She navigates using the sun as a compass, accounting for its movement across the sky in real time. She communicates flower locations back to the hive through a dance, the waggle dance, that encodes direction and distance with enough precision that other bees can find a specific patch of flowers miles away. She carries pollen in specialized baskets on her back legs. She can carry up to half her own body weight in pollen per trip. She makes around 10 trips a day. In her entire lifetime as a forager, 3 weeks, she'll fly roughly 500 miles total. Then, her wings give out. Not from a single injury, from cumulative use. The wing membrane just degrades, tears at the edges, until one day she can't generate enough lift to get back to the hive, and she dies wherever she lands. The hive doesn't send anyone to look for her. There are 60,000 other workers doing the same thing. But here's the part that actually makes this grim. If she ever needs to defend the hive, she dies for it too. The honeybee stinger is barbed. It's designed for stinging other insects, where the barb works fine and the stinger pulls clean. But human skin, or the skin of a mammal, is too thick and elastic. The barb catches. When the bee tries to pull away, her stinger, her venom sac, and a significant portion of her abdomen rips out of her body. She flies away with a hole in her abdomen and dies within minutes. The stinger keeps pumping venom into the target for up to a minute after separation. Evolution designed the system to keep working after the bee is already dead. She dies, the sting keeps going. That's how committed this system is to protecting something that will never protect her back. Now here's where it gets worse. There's a parasite called the varroa mite. It's about the size of a sesame seed. It attaches to a bee's body, specifically targeting a fat structure called the fat body, which bees use for energy storage, immune function, and overwintering survival. The mite feeds on this while the bee is alive. It's the equivalent of something latching onto your liver and slowly consuming it while you're still walking around. Varroa mites have spread to every continent except Australia. They weaken individual bees, they spread viruses between bees, and they devastate colonies. A heavily infested colony can collapse within 2 years. And they're not the only thing killing bees. Since 2006, beekeepers across the United States started reporting something they'd never seen before. Worker bees were disappearing, not dying in the hive, just not coming back. Colonies were collapsing to nothing, with no clear explanation. Full honey stores, a queen, plenty of food, no workers. They called it colony collapse disorder. It's 2026, and we still don't fully understand it. The current thinking is that it's not one cause, it's a combination of varroa mites, pesticide exposure, specifically neonicotinoids, habitat loss, fungal infections, and nutritional deficiency all hitting at once. The bees are being hit from every direction simultaneously. Here's what that means for you specifically. 1/3 of the global food supply depends on pollination. Almonds are 100% dependent on honeybees. Apples, blueberries, cherries, avocados, cucumbers, onions, the list runs to over 70 crops. Without bees working those flowers, the plants don't reproduce, and the food doesn't exist. The worker bee, who lives 6 weeks, flies 500 miles, works herself to pieces, and dies alone in a field somewhere, is holding up 1/3 of everything on your plate. We know what's killing them. We know the pesticides involved, we know the mites, we know the habitat loss. We're still using the pesticides, we're still losing the habitat. The bee doesn't get a choice about any of it. She just hatches, works, shreds her wings, and dies. The question isn't whether we can save them, it's whether we'll bother before it's too late to matter.